Now the next one is to know the difference between statistic and parameter. Statistic dealing with sample, parameter dealing with population. How can I tell when it is population sample? Population deal with the keyword of the word all element in the population. So after investigation, all, can you see this? All of 55,000 kilograms of meat, it found out that 45%, 45,000 of the meat was spoiled. But what is our sample is all about? About all. Therefore, this is a population, and population we mentioned is dealing with parameter. So B goes with the B. Be careful with that. Parameter population. In the next problem, but sample usually is a subset of the population. Be careful of that. In number 12, we are talking about the cumulative frequency. Cumulative, it keeps building up. That's one of the things you have to be careful about. So it's not going down like. So what we're going to do, we're going to see how we can build it up. So if you look at the sample right here for each class, so the first class right here, between 0 and 29, we have 4. We leave it as 4. So between 30 to 59, we're going to have 4 plus 16. So you always add to the previous class. So you go to this, you say, I'm going to add this and this. What do I get? I get 20. The next class, which is between 60 to 89, is going to be actually 20 plus 60, which is actually 80. So you're going to add all this together to get to that class. Now, in the last one, which is between 90 to 120, is going to be whatever you had before plus the frequency of that class, which is 100. So the last number right here must match the total number in the sample. So it's actually, if you look at the graph of this one, and if we actually uh, put uh, but over here the frequency, which is, let's say if we're dividing this by 20, 20, 40, 60, 80, 100, and then we want on the number line, and we go by actually um, so we put the speed on the y-axis and the frequency on the x-axis, which is we want 15. Let's say go to 15, 45, 75, and then we want to 105 and so on. So if you have this, so you could see very clearly the first class, which is between 20 to 59, we have actually 15, 4, which is very small, very close to the x-axis. And then after the next class will be 20, which is right here. Okay, any type between this and this, which is 20. And so what happened in the class right here, the frequency is going to be actually building up. It's going up, but it will reach the number of 100. It will not exceed more than that. So actually that's, I know that I tried to actually put this is the frequency on the y-axis, and this is the, it would be nice if we say the middle of the class. I'm not sure if we took the middle, but 0 to 29 halfway is 15 or 14. So you could say the first class we have 4, which is somewhere over here. The next class between, if we say 30, if I want to find out what's the middle point between 30 plus 59, divide that by 2, that's almost 44. So 45 is good enough. At 45 we have 16. So it should be a little bit less than this. We should have, if we want to be more accurate, we should have 16, which is somewhere over here. Now I'm sure that is somewhere some number between 60 to 89. So if we go to that, that should be 60, which is it goes all the way, jump to here. As you can see, it's moving up. And the next class is between 90 to 120, which is if we pick 105 or something close to that, then that will be actually close to 100. So the last one, it should build up to go to 100. So you can see the line segment, but that is actually the total frequency for that the size sampling in the ground. So this is actually called cumulative frequency. Cumulative frequency, and some other people they call it ogilvy. Ogilvy, which is a French word, but a French word for the cumulative frequency. So let's now look at the next problem, number 13. This is an ace was drawn from a deck. Find the probability of being an ace, or, here is the word, the key word right here, or heart. According to the rule of or, this is the probability of being an ace, having a heart be an ace, plus, since the word or goes with the plus, the probability of a card being heart. Then we're going to subtract the probability of if we have any ace that is heart. So ace and heart, and this being heart. And that's what the and goes right here. So we go, how many aces are there in the deck? We have actually 4 aces out of 52. How many hearts are there in the deck? There are 13 hearts out of 52 cards, because that's the total card in the deck. We have 1 ace, which is a heart, so we have to subtract the common element. Therefore, 4 plus 13 minus 1, and that should give me actually 16 divided by 52, which is equal to 4 over 13. Be careful with the or meaning we need to use the probability of addition. Now let's move to the next problem. The next problem, now you have a probability. First of all, we have 1,000 flights, 718 arrived on time. Find the probability that the flight will arrive on time. That's a straightforward problem. The probability of arriving on time will be equal to 718 divided by the total, which is 1,000. And then you will reduce this to, or you change it to decimal. But that is, you could divide that by 2. So if you take 718 and divide that by 2, you'll end up with 359 over 500. And that will be the answer right here. That's if the question asks how many they arrive on time. So if I want to find out how many is not arriving on time, then I'll subtract to find the difference. I'll say 1 minus whatever the probability right there, that will give me the one that's not arriving on time. Because actually, if we have 1,000 in total, and I subtract 718, so 1,000 minus 718, then actually 282, those are late. They will not arrive on time. So then we'll divide that by 1,000 to find the probability. But it depends on the question if they ask if they will arrive on time or actually the opposite. Now the next one, it's odd in favor or odd against. One of the things we need to be careful with when we say odd in favor, which is, let's go ahead and write this, odd in favor, basically that favor of A. So this is the success, number of success of A can happen to the number of failure, the unsuccess. Or the number of failures. So when we say how many, when we say the probability of a 4 to 7 for, so if I write it right here, total right here will be 7, 4 will happen, and 3 will not happen, because that's the difference between 4 and 7. Will not, so be careful with the word not. Maybe we should put it in color, not happen. So when they ask odd in favor of A, success of A, how many are there success of A? There are 4 will happen. Therefore, over here, unsuccess will be how many? There'll be 3. So be careful when you find the, this is what it means right here for the probability. 4 to 7, or actually the odd in favor of A, 4 to 3. The total number right here will equal to the total number in the denominator, which is 7. 4 plus 3, which is 7.